we're going to start to define muscle tension. So muscle tension is the force generated by a muscle. Everybody knows that muscles contract and they shorten, and that's contraction. And the whole purpose is to generate a pulling force, either to cause an extension or a flexion of your arm or different movements of the um, limbs with muscles attached. A muscle twitch is a brief contraction relaxation in response to a single action potential. So this is a twitch. So as the muscle contracts, the force generated, the tension increases very rapidly within about 5 milliseconds or 6 or 7 milliseconds. And there's a little latent period when the stimulus hits. And so when this contraction starts, the acetylcholine has to bind to the sodium channels, let sodium in. Sodium causes the inside of the muscle fiber to become more positive. That causes release of calcium that has the active sites on the myosin exposed so that the myosin heads can join to those active sites on the actin. And since they're energized by ATP, that uh, forward movement of the myosin head and its tail cause the sarcomere to shorten, and that's how muscle contracts. So with a single nerve impulse, you can have a twitch that develops maximum tension, and then the muscle relaxes. Okay, so the frequency of the muscle fiber stimulation is going to cause processes called summation, incomplete tetanus, and complete tetanus. So summation is the addition of individual twitches, and it's applied before the muscle has relaxed. Uh, Twitch tension can be very rapid contraction and relaxation, or when the frequency is high enough, you can increase the muscle force or muscle tension developed by the muscle. So how does that happen? So you can have a stimulus that are separated. So the muscle contracts, begins to relax, and then it's able to, once it's recovered, to contract again. So by having frequent nerve impulses hit the muscle, you can begin to that summation. You may not know this, but back when I've taught biology and I've taught dissected frogs many, many times. People back in the 16 and 1700s found that they could stimulate the nerve from a frog leg, and the frog leg separated from the body of the frog would contract. So the frequency of those stimulations from the muscle lead to summation. So the frequency is here, the muscle begins to contract, and then it contracts again before it totally relaxes. If the frequency is close enough with each impulse sent by the nerve, you can get called what's complete tetanus, and that's how you develop maximum tension or force by a muscle. So you can see that the tension developed is maximum at the complete tetanus. So the muscles contract and very little or no relaxation. So that's called complete tetanus, incomplete tetanus, and summation is the process by where these twitches, depending upon the frequency of the motor nerve stimulations, can cause complete tetanus. So what's a motor unit? A motor unit is the neuron and all of its muscle cells that it controls. So when the number of muscle motor units are uh, increased, depending upon how much force the muscle has to generate, it's called recruitment. Small motor units, muscles attached to the eyes, to the muscles in the iris, and where you have fine, small muscles, you can have small motor units. The stronger the muscle, or the bigger the muscle, and the bigger its load, so the muscles of the thigh with the uh, adductor longus and the different muscles in the thigh, they have to carry much, much higher load because they're attached to the femur, which is the largest bone in the body, and they have to move the leg around. So there's going to be many, many, many muscle units, motor units in the muscles that allow for movement or flexion and extension of the upper leg. So if you have a muscle and you have the cell bodies of the motor axons, uh, you can see that there's three motor units. 1, 2, 3, 4. No, 1, 2, 3. Motor unit 2 is blue. 1, 2, 3. Motor unit 3, which is, you can see that the number of muscle fibers where the axon terminal makes a synapse between the muscle and the nerve. I'm sorry, between the nerve and the muscle. Those are motor units. So a motor unit is the motor nerve and how many muscle fibers it's attached to. For a muscle fiber to contract, it must be stimulated by a nerve. So motor unit 3, let's see, 1, 2, 3. They didn't vary the number much, but it looks like motor unit 1 has 1, 2, 3, 4. Motor unit 2, 1, 2, 3. And motor unit 3 has 1, 2. Okay, so a motor unit is the number of muscle fibers that the motor nerve has axon endings or synaptic endings and forms a synapse. Then below that is the motor end plate of each fiber. So all intentional movements, most of them are subtetanic contractions. The number of skeletal muscle fibers that are activated, you can increase the amount of force by the number of motor units that are stimulated and increase the frequency of action potentials. So you can increase the force generated by a muscle by increasing the frequency and by recruiting additional motor units. Muscles have muscle tone. For you to sit up, for you to walk, you have to have a resting tension. So the muscle has to maintain contraction to hold your back up and your buttocks pressing against the chair, and it has to have a certain level of muscle tone so that when you were a little baby, we could take you and your parents could put you on the floor and they would put you in a sitting position and all you did was fall over. So muscle tone is the process where you learn to walk, learn to sit, learn to ride a bike, learn to drive a car. All of these interactions of your skeleton and muscle have to maintain tension depending upon the needs at a particular joint and the bones to which the muscles are attached. Okay, let's stop there. Go back to here. Let's take a 10-minute break, and I'll be back momentarily. And